Okay, how much work will be done to bring an object 80 meters above the ground? Of course, I know if I want to bring it from here to here, I have to apply force equal to mg. The green one is the one that is doing the work for us, and this is the formula for work. This is the answer. I don't have the mass, so I have only g and maximum h, which will give me 800. M is mass. In here, this m is mass. So n 800 m joules actually. Because I don't have the mass, I write it as m. So the second one, potential energy in that height. Of course, I know the potential energy in this height, which is the maximum potential, would be mgh. So I will have m like this is the EP max, which is mgh, and is again m times 10 times 80, which is 800 m joules, the same thing, because we know the work is actually saved as potential energy. The work that we do to bring it here in here is saved as potential energy. The number 3 is asking the velocity when it's hitting the ground, because when I have it here, then I let it to drop and it's gonna hit the ground with what velocity. I know that that would be actually my maximum kinetic energy, which is v square, and this is the maximum v that I have. In here, I know that the EP equals E k, so that mgh that I had, the maximum, would be equal to this, and this m's would cancel from both sides of the equation, so the gh equals half v square. I bring it here. The v square would equal 2gh, and in order to find the v, I would need a radical here. So this v, which is the maximum v, would be actually radical 2 times 10 times 80, which would be radical. So the answer would be for me 40 meter per second. Now let's solve the part number 4, which is asking for velocity when I am 60 meters above the ground, which I am in this point, and in that point I have both potential energy and kinetic energy, but of course less of each, but the addition must equal this and this. I choose this one, which is easier for me at this point. So I will have mgh maximum equals mgh plus this one. These are not maximum, but this is the maximum. So I factor the m in here, and then I cancel it. So the gh equals gh plus half v square, and therefore the gh minus this gh, and this equals half v square. Of course, the 2 goes to the other side, goes to the top. Gh minus, or I can even make it even simpler. I can say 2g, I can factor out g, h minus h equals v square. So the v would be radical 2 times 10 80 v square equals radical 2 times 10 80 minus 60. V square equals 20 times 20. Of course, obviously the v would be 20 meter per second.